Hello and welcome back to Mrs. Law's class. In this lesson, we're going to take a look at how negative exponents work. Now, instead of me just telling you how they work, let's do a little investigation. So you've seen a similar table like this before. So what we're going to do is we're going to start with some positive exponents and work down to the negative exponents. So 2 to the power 3, we know how that works already. That is the same as 2 times 2 times 2. And that, in standard form, is 8. 2 squared is 2 times 2, which is 4. 2 to the 1 is just a single 2, and we know that's 2. Now, 2 to the 0, remember, that's a special one. And that gives us the value of 1. Now, looking at just the first 4 numbers, we can see that as we move down the table, we divide by 2. So therefore, if we follow the same pattern, if I take 1, I should be dividing by 2 to get the next power. So the next power is 2 to the negative 1, which means that if I take 1 divided by 2, that should give me a half. So this repeated multiplication is just the single fraction half. Now, if I divide it by 2 again, I would get a half divided by 2, which is the same as saying times 1 over 2. And we know that 1 over 2 times 1 over 2 is 1 over 4 in standard form. And then finally, let's divide by 2 one more time. And so we have half times a half. And again, dividing by 2 means we're going to multiply by 1 over 2. So half times half times half is 1 over 8. Now, what I also want to do is not just write the value of this power in standard form, but I'm actually going to now rewrite this also in power form. So half would be the same as 1 over 2 to the power of 1. 1/4 is the same as 1 over 2 squared. And then 1/8 is the same as 1 over 2 cubed. So notice the pattern over here. So when it was 2 to the negative 1, it actually has now become 1 over 2 to the power of 1. 2 to the negative 2 has become 1 over 2 squared. And now the exponent's positive. And same with 2 to the negative 3. It has been now written as 1 over 2 cubed with a positive 3 exponent. So looking for patterns in the columns, we fill in the standard form for the powers with negative exponents. So this is standard form down here in the middle column. In power form, as the exponent decreases by 1 each time, its standard form is divided by 2 or multiplied by a half. So therefore, we can write or rewrite a power with a negative exponent as a power with a positive exponent by writing the base as its reciprocal. So, like I said before, 2 has now become 1 over 2. 2 to the negative 2 has become 1 over 2 squared. Now, this is applied to the base where the exponent is placed. So the negative exponent rule states that any base, except for 0, which has a negative exponent, can be written as the reciprocal with a positive exponent. So, for example, if you have a to the negative n, that is the same as 1 over a to the power of n. And then a can't be 0. Now, all the rules and laws that you have learned from before also apply to the negative exponents. So all your power of a product rule, power of a quotient rule, power of powers, they all apply also to negative exponents. Now, sometimes you will find that it is easier to apply the exponent laws before making the exponent positive or applying the negative exponent rule. So let's take a look at some examples. In these first examples that we're going to take a look at, all of these expressions have variables in them. And then we're going to look at other examples where they are numbers. So rewrite the expressions with positive exponents. So here we have a to the negative 2. And using our negative exponent rule, we would then rewrite this as 1 divided by a to the power of positive 2. In the second one, we have two variables. Both of them have a different exponent. Both of them are different bases. So this is still going to be 1 over. B is reciprocated and brought down to the bottom with a positive power of 5. C is also brought down to the bottom with a positive exponent of 7. Okay, in example 3, notice that the negative exponent is applied to everything inside the brackets. So doing the same thing, we're going to go 1 divided by, we're going to leave the brackets. So we have 6x. Instead of negative 2, when we take the reciprocal, we're going to write a positive 2 exponent. And then we can actually even rewrite this as 1 divided by 6 squared times x squared. And if we want to simplify it even more, we can write this as 1 divided by 6 squared, which is 36, times x squared. So notice the 2 is applied to both the 6 and the x when we use the power of a product rule. Now we're going to do the last one here, and we can do something similar. We can do what we did for something like question number 3, or I'm going to show you another thing that we could do instead. We can also apply the negative exponent first, or the exponent on the outside first. So remember that we take the exponent on the outside and we apply it to every term on the inside, or every base. So here we now have 3 to the power of negative 3 times x. Now this time we actually do have an exponent here. We have a negative 4 and a negative 3. So we're going to multiply these together. So we have negative 4 times negative 3 to give us a positive 12 exponent. So what's happening is the negative 3 exponent on the outside is being applied to the 3, or to the 1, I guess, the 1 exponent on the 3, and the negative 3 is being applied to the negative 4. And remember, we multiply exponents when there's an exponent inside and outside. All right, so the question's asking us to rewrite the expressions with positive exponents. Now, x to the 12 already has a positive exponent, but the base 3 has a negative exponent. So what we're going to do is we're going to rewrite this. X to the 12 will still be in the numerator, but the 3 with a negative 3 will move to the denominator because it has a negative exponent. And when it moves to the denominator, it becomes positive 3 exponent. And if you want, you can change this to x to the 12, and then 3 cubed is 27. All right, let's try some questions where they are all numerical, and we also have to evaluate afterwards. So first one, nice straightforward one. We're going to write this as 1 divided by 5 cubed. So when we move the 5 to the denominator, the exponent becomes positive. So now we have 1 divided by, and 5 cubed is 125. All right, same thing with the next one, just one single base. So we're going to rewrite this as 1 divided by, in brackets, negative 9. Negative exponent 2 becomes positive 2. And then negative 9 squared becomes positive 81 because it's negative 9 times negative 9. All right, in the next one here, we have a negative, but notice that this time there's no brackets that includes the negative sign. So the negative will stay up here. We're going to write this as negative 1 divided by the 2, which is the base of the negative exponent, moves to the denominator, and then the exponent becomes positive. So now we have negative 1 divided by 2 to the power of 4, which is 16. All right, in this next one here, I'm going to show you something. So the only difference between this one and the other ones that we've done is that this one has a base that is a fraction. So if we rewrote this, don't write this yet, it's 1 divided by, and then 1/3 to the power of positive 4. Now that seems very cumbersome and very big, since we have a fraction within a fraction. Now, if I kept going with this, I would now have 1 divided by, and we would then use our power of a quotient rule. We're going to apply the 4 to both the numerator and the denominator. So we have 1 to the 4 divided by 3 to the 4. And then this would then become 1 divided by 1 over 81. But remember that this actually means 1 divided by 1 over 81, which is then 1 times 81 over 1, because when we divide a fraction, we multiply by the reciprocal, so this really is just 81. Now that's a really long about way to do this. So based on our negative exponent rule, let's go back. We can just take the reciprocal of the base. So when the base is a fraction, instead of saying 1 divided by and then 1/3 to the power of 4, I'm just simply going to take the reciprocal of the fraction to now be 3 over 1. And then my exponent, instead of being negative, is now going to be positive 4. So now I have 3 to the power of 4. I'm going to apply that. And then 1 to the power of 4, which you don't really need to do because 1 to any power is going to be 1. So I won't write that denominator. But now I have 3 to the power of 4, which equals 81. And you can see that this is a much quicker way to do this instead of rewriting this as 1 divided by another fraction. So let's try this again with example number 5. Okay, so we're going to take the reciprocal of our fraction. So it's going to be 5 divided by 3. That's our base. The negative exponent 2 becomes positive 2. Apply this to both the numerator and the denominator. So we have 5 squared, which is 25. 3 squared, which is 9. All right, the next one here. Now, before I actually use the negative exponent, let's use my multiplication law, where I'm going to have, since I have the same base, I can add my exponents. So 1 plus negative 2 is negative 1. And now I'm going to use my negative exponent law to state this is 1 divided by 8. Instead of negative 1, I can write a positive 1. Now, actually, I don't usually write a 1. If the exponent's 1, we don't write anything down. So I'm going to actually erase it. All right, next one here. Now, we're going to, this time, use our power of a power rule. So we have an exponent on the inside of negative 3, an exponent outside of negative 2, and we're going to multiply those together. So we have 2 to the power of 6, so we're going to multiply. And now we just have to evaluate the positive exponent, which is even better. So 2 to the power of 6 is 64. All right, last one here. We notice that the negative exponent is only being applied to the base 4. Okay, so when I draw my fraction line, the 9 stays in the numerator. We don't take the reciprocal of 9, but we do take the reciprocal of 4, which is then going to be 1 over 4 in the denominator, or we're going to say that 1, or let me write this like this. So we can think of it as 9 times 1 over 4, and this will be positive exponent of 3. And then when I multiply this together, it'll be 9 times 1, which is 9, and then 4 cubed, which is 64. So actually, instead of writing it as 9 times a fraction, you might also want to rewrite this as 9 over 4 cubed, which is then how it becomes also 9 over 64. And that's how you can work with negative exponents.